If you're in the back of the room and your name is Basil and you can hear me, raise your hand. All right. If y'all wouldn't mind, please take your positions. The discussion in the back was amazing at the poster sessions. I get the feeling that people don't want to leave that area, but you can go back during the break, it's fine. So I thank you for that. And I wanted to read you something. So Ben Boleski, who has been online today, I don't know, is the Zoom going, y'all? Okay, I'm going to read a text that he sent me about the student presentations. The academic curiosity, substantive research, and stage presence of the students are absolutely inspiring. Just saying. So good job, y'all. So Claire, any last instructions for the judges that you need to relay?
Just make sure you give me your sheets.
Okay, get your judge sheets to Claire, please, and she will tally those, and we'll have the results at the end. And now I think I'm turning it over to Tina as the moderator. All right, Tina.
Thank you, everyone. And yes, if you could just continue to make your way to your seats so we can remain on time and hear all the wonderful speakers for the afternoon. I also just wanted to take a moment and acknowledge that this Friday is Earth Day. So happy Earth Week to everyone. And thank you for everything you all do for making it a better planet. So without further ado, I'd like to introduce Dr. Eban Bean, and he's been supported on this next talk by Ronald Fox in assessment of soil amendment types and rates for reduced turfgrass irrigation.
Truth be told, Ron did this research and I supported him on this. So yeah, we're gonna go from there. So we're going to be talking a little bit about a study that Ron led as part of his master's thesis, looking at the impact of soil amendment types and irrigation rates on turfgrass quality. To get some background, I just want to kind of point you to, we have a manual that is online that basically is guidance for how to do amending of urban soils. Kind of walks you through sort of the background of what the issues are with compacted soils in urban landscapes, the background on the different qualities of organic soil amendments and how to implement this. So if you find if you just search for the title there, it should come up and is a good resource. So we've had several studies that have looked at doing sort of feasibility of using compost to improve soils in new urban landscapes. So this is basically incorporating compost into the top 6 inches just before irrigation lines and sod goes down. Basically the last things before you walk into the house, or basically the house is done. And so some of those studies, we had some good results that were basically establishing the foundation that compost does improve the soil quality and improves the soil-water relationship. And so we wanted to take this a few steps further to look at really answering a few key questions. The first one is, how much can we reduce the irrigation by? In some of our previous studies, we had shown that it was feasible to reduce irrigation by 25%. We wanted to see how much we could push that by. Some of our studies had kind of shown that maybe 25% was conservative. How much compost is needed for these impacts or benefits to be determined? The first one, the recommendation right now is about 4 cubic yards per 1,000 square feet. Do we need to put all that material in? Can we still get the same benefits or about the same benefits using a little bit less and reduce the amount of nutrients that are coming into the landscape with the compost? And then not all compost is compost. What your neighbor kind of produces in their backyard is not going to be the same thing that you get from a commercially produced material. So looking at, are there differences among the different products that are available on the market? So we looked at 5 different compost materials, and we've anonymized them here, A through E, and looked at sort of their characteristics, just kind of providing sort of a snapshot of what their kind of different properties were. You can see there's a good range between the total phosphorus, and the total phosphorus oftentimes is the difference in that is due to the differences in the parent materials. So oftentimes higher phosphorus is coming due to higher phosphorus in your parent materials. Nitrogen generally was about in the same range, typically around that 12 to 14 milligrams per kilogram, 12 to 14 milligrams, 12 to 14,000 milligrams per kilogram. pH, mostly in that 6.5 to 7.5 range. We did have one that was a little higher. And then organic matter. So we do have some ranges here on the bottom. The acceptable ranges are from the U.S. Composting Council's Seal of Testing Assurance. We basically use their ranges as the recommended range of properties for compost materials, just in place of having anything of our own at this point. And then the carbon to nitrogen ratio, typically 15 to 25. And we had a few materials that were outside of these recommended ranges. We had one that had a higher organic material content, about 70%, when we typically want to cap that at about 65%. And then moisture content was a little bit low for product D. So looking at the designs of these studies, we had 120 plots at the Citra research site down halfway between here and Ocala. We basically had two studies that intersected, okay? So this plot here shows the treatments that were applied to all 120 of those plots. 64 of these plots, the white and the hatched squares that you see here, basically we're looking at different amendment types and irrigation rates. So we had 4 irrigation rates, essentially 75% of the IPIS recommendation, or a 25% reduction, 25% of the IPIS recommendation, and then non-irrigated. And then we had 50% of the 50% of the IPIS recommendation, that those are basically coming from the crossover with the gray study, or the gray boxes here. They're the hatched ones. We were looking in this aspect at 4 amendment treatments, so control, no amendment, no tillage, just flat compacted soil, and then 3 commercially available products, A, B, and C. All of these were applied at 4 cubic yards per 1,000 square feet. This is about 1.3 inches, a little over an inch, and that's tilled into the top 6 inches, and we had 4 replicants. The second study, the gray boxes and the hatched, we're looking at amendment type and amendment rate. So we were looking at 6 amendment treatments. So we had a control and 5 amendment products, A, B, C, D, and E. And then we looked at 3 different amendment rates, high, medium, and low, at 4, 2, and 1 cubic yard per 1,000 square feet. All of the gray boxes and the hatched were irrigated at 50% of the IPIS recommendation. And we had 4 replicates on this as well. So we installed this. The study began in August of 2019, where we put down the treatments and applied the different rates of compost, tilled them in, and then sodded them down. So you can see what it looks like. You can see the different ranges in dark versus light plots, showing kind of the high versus lower rates of compost. And then you can see sort of the visual progression from June 2020, September 2020, things were looking really good. We got a really cold snap at the beginning of December 2020, and everything basically went dormant. We got an early freeze and basically went dormant right after that. This study went through the end of 2021. And you can kind of see the progression in turf quality from the beginning of the season in March, May. We typically have a dry spell in May, and you can see sort of that stress that was coming out of May and into early June, kind of differentiating the different treatment types. July, we've got a little bit of recovery. And then in late September and November, we started to get some issues with chinch bugs. We had treated for the chinch bugs on a fairly regular basis, what we thought should have kind of addressed that issue or been preempted, but we ended up having severe damage to several of our plots anyway. So we talked a little bit about sort of the data collection that we did and kind of look at some of the key results. We took soil samples at the beginning and end of each growing season. Soil samples were collected for bulk density, soil organic matter, pH, nitrogen, and phosphorus content. And that was so basically 4 times during this study. And then approximately weekly, we estimated or evaluated, I should say Ron evaluated the turf quality. I was like, I can't say that I did that. Turf quality on a weekly basis. And he also tracked the water balance, essentially looking at irrigation, rainfall, and ET. So looking at bulk density, so we have 4 plots here, or basically 4 points in time here. We have the beginning of 2020, the end of 2020 growing season, the beginning of 2021, and the end of 2021. And you can see that particularly in each of these, you have the 0 is our control. So bulk density is the maximum for your control. And then as we incorporated more and more compost, the bulk density went down. And you should see that trend essentially across the board here. It's not always exactly that way in each time scale or each time step and each amendment, but essentially that's the general trend. We do see that in general over time from year 1 to year 2, the bulk density, even in the control and the amendments, decreased on its own as well. But essentially as you increase the amount of amendment and over time, we had a decrease in the bulk density. Soil organic matter. So we saw that in the first initial sampling, as we increase the amount of compost, we increase the amount of organic matter. Interestingly, we didn't see a consensus on what the trend was with soil organic matter. Year 1 tended to be an increase from the beginning to the end of the growing season, but then the next year in 2021, some places we saw sort of a decrease, some places it still increased, so not a real consensus there. pH was also somewhat interesting. We had a range in different pHs for the materials that were incorporated. So all the way from about 6.5 with product B to 8.2 with product E. And as we see, the more compost we add, the more that pH gets closer to what the pH of the material is. Interestingly, year 1, from the beginning to the end, we saw that there was sort of an increase in pH. And then in year 2, we tended to see that there was a decrease in the pH over time. We'll kind of get to some of the reasons for that here in a moment. Total phosphorus, the first year, we tended to see that the total phosphorus increased, and we think this was probably due to an application of phosphorus in the maintenance program at some point. But then year 2, we don't see really any increase. It stays fairly stable there. Total nitrogen. In year 1, we sort of see an increase where it's starting to retain more nitrogen during the year. But then in year 2, from the 2021 February to October, we generally saw a slight decrease in the nitrogen and a loss of that nitrogen. So again, kind of go into that more in a minute. So irrigation. So if you remember, 2020 was a bit of a strange year. There was COVID, so we had intended to start this study, basically apply the irrigation treatments in, I believe it was March, and basically right around that time was when COVID came on, everything shut down, we couldn't travel. At that time as well, we had some issues with the irrigation on the site. So this first year, you'll see that the 25, 50, and 75%, you'll see that the May time period, we had some major leaks. And so we had a lot of water that was being applied onto the plots. But after that, it kind of settled in, and you should see that the top row is about half of the second row and about a third of the third row. And you can see in year 2, our irrigation amounts are much more in line with what we would have expected. So very much fewer issues to deal with. So turf quality rating, how do we go about this? So there's the National Turfgrass Evaluation Program. This is a standard way to evaluate the quality of turfgrass. And typically you can kind of see some examples here of what we generally saw, which was about a 3 up to an 8 for the plots that were there. The NTEP standard is a 6. However, from some other studies that have been done in Florida, they've shown that a 5 is probably acceptable to the homeowner. So we set that as our threshold for acceptable turf quality. All right, so let's get to some of the results. So there's going to be there's going to be several of these graphs that look at the turf quality of the different amendment types. So here we have our control, which is just no amendment, compacted soil. We have the amendment type A, B, and C, the different products. And then what our average turf quality was for each month. And you can see sort of the bar chart on the left that kind of gives you sort of that gradation from a 1, what a 1 score is, up to a 9. And so what you see initially here is in March of 2020, we don't really have much difference between the treatments. We didn't really implement our irrigation treatments until June. So you can see that there's not a whole lot to be of difference at that point. And this is the non-irrigated treatment. So we weren't actually getting any irrigation from June through the rest of the year. You can see that for the most part, the controls stayed below 5, and most of the products stayed around the 5. It reached about that acceptable level in September, October, and November. But then come year 2, the second year of the study, none of these plots were basically deemed to be survivable or feasible. So several of these would be basically be failed landscapes. Okay, so we determined non-irrigated is not possible with 4 cubic yards. About 75% reduction, so only 25% of the IFAS recommendation. Well, again, starting our treatments, our irrigation treatments in June, we definitely see that there is a benefit to the different compost products over the control for several of the months here. When we go to year 2, though, our scores drop notably. But we do have some of them that reach right at the 5 in June, but there's not really a big significant difference between the controls and the treatments for the most part. So this is looking at where we had the 5 products and comparing 50% of the IFAS irrigation recommendation and the 1 cubic yard. We're going to start with 1 cubic yard per 1,000 square feet treatment. So we see in this case with 50% reduction and only one cubic yard, all of our treatments in year 1 between June and November met that sort of turf quality standard of 5. Okay, so good news. And we do see that in general, the compost has about 3/4 of a turf quality point improvement over the controls. Year 2, not as bad as the 25% with the unirrigated. So we tended to have for 3 out of the 5 products, can I maintain that 5 turfgrass quality score or better throughout most of the year, all the way through December. The controls, obviously a notable difference when we get into August and later, the controls basically drop off, and products B and D also tended to drop off in quality from August through to December. When we go up to 2 cubic yards per 1,000 square feet, kind of a better performance with the turf quality. All of our treatments in this case were basically above that 5 from June through November in the first year. And the second year, we had much more of a higher retention of the turf quality in our June and July. And then we maintained turf quality for C and E through the end of the year. Now, interestingly enough, with more compost from product A, we didn't have as good a turf quality. Every once in a while, we saw that with some of our products. 50% reduction in 4 cubic yards, definitely, did very well from our controls compared to our amended plots. Still not a lot of difference between the different compost products throughout the main part of the growing season. Looking at year 2, a little bit more separation that occurs, again, kind of in that August through December timeframe, where we have much better quality through June and July than when we get into the later part of the summer season. And we see a little bit of differentiation, but not as much. And then looking at the 25% reduction with 4 cubic yards, if we're doing 75% of the IFAS recommendation, we had even our controls were meeting that minimum 5 standard in the first year, although our amended soils were having 1.5 points maybe of turf quality improvement over that standard. And then in the second year here, we also see that pretty good through July, but then once August, September, November, December kind of drop off, the scores kind of drop off in that time frame. Interestingly, in some of these, we actually had a lower turf quality average score than the control. Something we may want to look into a little bit more there, but at least in this situation, product A seemed to persist with a higher turf quality than B and C. So kind of summarizing this a little bit, looking at the amendment type and irrigation, year 1, not a lot of difference between our different irrigation rates of 25, 50, 75%, or between our amendment types, A, B, and C. A, B, and C all had a notable increase in quality over the controls. However, when we go to year 2, the 25% basically was not feasible, and it was not feasible to continue with the study. It had sort of failed landscape would occur essentially at those irrigation rates. And then we did have all of our treatments on average in that second year with 50% or more irrigation, meeting that minimum 5 standard on average. When we look at turf quality rates and types, so looking at our amendment rates from year 1, 0 is our control, 1, 2, and 4 being our amendment rates. What we kind of see is that 1 is better than the control, 2 is better than 1, but not quite as good as from 0 to 1, and then 4 is better than 2. So we have definitely a benefit. Not as much of a we didn't retain the same turf quality ratings in the second year. Our controls definitely would have failed with an average score of 3.5 throughout the year. A, C, and E tended to perform slightly better than our B and D products. However, in most cases, those are not significantly different in our based on the variability there. So if we go back and look at sort of summarizing, some of these key aspects of the different products, remember A, C, and E tended to be kind of separate themselves slightly from the other 2 products, so B and D, and note that product B had a higher organic matter than what's recommended. So that may be sort of a potential rationale. If it's not completely composted, not completely mature, it could continue to compost and break down organic matter in the soil. As that carbon kind of, with that higher sort of carbon that's available, we might also have sort of less nitrogen that's available. So we have one of our higher carbon and nitrogen ratios. And then our moisture content was pretty low for product D relative to what we would see as being ideal. So maybe those are some aspects there. Looking at years, okay, good, yeah, all right. Looking at years 1 and 2, there were some differences in our rainfall when we look at sort of that critical period from July to September. So in year 2020, what we had was much more regular rainfall, where we had sort of the afternoon storm on a every 2 or 3 days. We had, and I should mention, we had about the same rainfall in year 1 as we did year 2, but it came at different intervals and different intensities. So if you can see in sort of year 2, we had much more intense rainfall or much higher rainfall events, but much longer durations between those storm events. And we think this may have been something that caused the turf grass to be stressed a little bit more and be more susceptible to other factors that degraded the quality. So our plot study conclusions were benefits of compost basically diminished as you increase, but we see sort of somewhere in that 2 to 4 cubic yards per 1,000 square feet is where we should go with the compost amendment rates. Non-irrigated and 75% reduction were not found to be feasible. So we are recommending a 50% reduction in IFAS recommended irrigation amounts for amending with compost. And then the amendments in general were fairly similar. It's something we need to look into a little bit more as far as what the actual characteristics were that drove the differences in performance, particularly in the latter half of year 2. And we did have some differences in our properties of the compost. I will say that we're going to continue this study for at least another year, maybe 2 years, to kind of see, was year 2 representative, or is it just a fluke and year 1 is more representative of what we should see? So we haven't really determined what the drivers behind all that was. So acknowledgements, Ron Fox, Michael Dukes, and Bernard Cardenas, Layla Carr, where's Bernard? Yeah, there, Bernard, helped a lot with getting this study set up, along with Tony Brown and the Citrus staff, along with several grad students that helped out with a lot of the data collection. I want to acknowledge Scott's Miracle Grow, Life Soils, our Harvest Quest, who helped with providing us with products, and several of our funders, Tampa Bay Water, Swift Mud, FTGA, and FNGLA, who helped make this possible. So we have a little mile. All right, I'll make it quick.
And we do have a Zoom question if you'd like to start with that.
Sure.
So Doris asks, how frequently does the soil need to be amended after the original application?
Okay, so Doris asked, how frequently does the soil need to be re-amended after the initial application? I repeated it just like you said it, right? Okay, so when we talk about amending, what I'm talking about is the actual incorporation and the tilling of the soil. So this is breaking up any structure that's in the soil, and then you have to resod it. So we wouldn't recommend that you have to redo that on a regular basis. What we're looking at is you would probably want to top dress this to replace that organic matter that may be lost. But that's a question that we don't have a good handle on right now, is sort of the longevity of the initial incorporation. We have seen in other studies where the impacts and effects have persisted for at least 2.5 years, maybe even longer. So we don't know yet, but we're something we're going to be looking into a little bit more. Yes.
I might have missed that, but what was the turf type?
I'm sorry. Great question that I didn't mention. I should have. It was St. Augustine Floratam. Yes, Tatiana.
Did you, and this is just curiosity, take data on what treatments were preferred by the chinch bugs?
We did. So the question was, did we take data on which plots were preferred by the chinch bugs? We did not, but it was tended to be the ones that were lower on the irrigation. So essentially what's happening is the chinch bugs are chewing away at the vegetation. And when you don't see the damage, the vegetation is able to compensate and keep up with that. The ones that were basically not irrigated as much were not able to grow and regenerate quick enough to keep up with the damage that was occurring. So yeah. I got one in the back, Michelle.
Do you have a ballpark cost for like 1,000 square feet or something of what this is?
Thank you. Yes. So what is the ballpark cost of the of putting out the compost? That's going to depend on the producer and applicator, but we tend to estimate, a ballpark figure for a 1/4 acre lot. That's half of that is a home, and half of it is landscape, and half of that is maybe 60% of that is turf. You're doing that maybe about $1,000. That's going to vary by all that.
Let's give Dr. Bean a round of applause.